Welcome to the talk having a title, I Interface What Your Mom Didn't Tell You About the Interfaces. Really briefly about me as Jason. I'm a family guy, smart and beautiful wife, 2 kids, bunch of interests. I'm blogging from time to time. I have a current favorite quote of mine by Homer Simpson, bad decision isn't bad if you know it's bad. I work for the company called Volue, and this presentation will be full of opinions, so bear that in mind, please. Some inspirational quote from me, a mind is like a parachute, it works best when it's open. And by that, we can just start. So, a quick agenda. We'll talk about interfaces, then have some examples, and then eventually, maybe we'll have some conclusions. So let's start. Who knows or used or read about interfaces? Pretty developers? Yeah, probably yes. Okay. So, before Einar was presenting us the categories and all those kind of things, so I like to start with the definitions, just to put up the frame to know where we are together, right? And I found this definition, that an interface is a point where 2 systems, subjects, or organizations meet and interact. It is a nice definition. But I was wondering about some programming category definition, just to make it more familiar to us. And I thought about this. The thing that enables using dependency injection. Easy, right? Exactly. So, because the dependency injection is the nirvana, we are trying to reach that, to get the loose coupling to through the open-close principle using the IOC container. This is all about that. Any C# developers or past C# developers? Yeah, that's nice. You'll be converted. No worries. No, I'm joking. Of course not. I'm asking about that because there will be some examples in C#, but I believe that those principles or those ideas are more agnostic. But let's see. So, how many of you did see something like this? That there is a public interface, user interface, and it's followed by the public class user service implementing that interface. Amazing, I would say, right? So there is a great mystery that an interface called your important name service is followed by this kind of single implementation class, your important name service. Of course, it's a .NET thing or a C# thing to put in the front of. We are a pretty interesting tribe, I would say. Probably in Java it would be your service and then service impl or something other weird thing. But still, I was wondering, doesn't it look suspicious? It's a bit interesting thing to have it in the wild, to see exactly the same interface or almost the same named interface followed by the astonishingly similarly named class. So you can say, Damian, did you hear about CQRS? Who knows what CQRS is? Who uses that? Okay, so basically it stands for Command Query Responsibility Segregation. So it's all about taking all the methods and putting them either as commands or queries. And don't get me wrong, I really like CQRS, but also I believe that we misunderstood the ambiguity of the interfaces along the way. So you can say, well, what? How we misunderstood the interfaces? And I believe that we should do a small experimentation here, a really tiny example. And in this example, we'll see along the way how it goes and what we can learn. So imagine that we are working in a certain software company on a product, and we need to help within the area where the feedback is a central concept. And of course, there is a feedback service and feedback service interface, right? That will be seen in the implementation. And it has a bunch of methods. We can give feedback, approve feedback, disapprove feedback, and also we can get all the feedback by some feedback subject, a typical enterprise level of business, right? It looks basically okay or incorrect, not incorrect, right? And imagine that we need to test some part of the system by using only this single method. What would we do? Probably we'll just mock the rest and we'll live like that, or just have a next implementation with not implemented exception, probably like this. And someone can say, of course, This can be solved by the CQRS, like Damian. Did you live under the rock for those amount of years, right? You can just create commands, queries, and everything will be solved, right? What are you talking about with these interfaces? And that's true. It's basically everything. Thank you very much. And we are all? No. There is more that I would like to explore with you, because it's a vastly interesting topic. So in our consideration, we have an interface with 4 methods. Who have heard about solid before? Okay. So we might say that in the solid, using this principle of thinking, we have an interface that has a defined set of methods that are about the central concept of feedback. And some senior software engineers might say that, oh, it follows the interface aggregation principle because it's well bounded by those methods around the central feedback concept. But such pairs create some kind of phenomenon that an interface with exactly same name as the class has occurs so often, so frequently in the wild. And I was wondering why. And also I was wondering how to create such structure. And I figured out 5 points, sorry. So first point is we need to create a class named accordingly, preferably after the noun. It is very important, after the noun. Then we are basically adding public methods, immediately populating with code, with the implementation details. Next, we are creating the interface based on this class, probably with the same name, and for the .NET Pros, we'll just add I in the front, right? Oh, sorry. Then we need to make sure we cover all the methods, and then we can use this interface in tests, right, by mocking, simple, right? But this recipe creates something in isolation, far from the feedback from its consumers, right? By using some specific way of thinking. And it's very, very often occurring that this interface is created after we are getting any specification of its behavior. And not to mention, I'm not talking about tests, about just knowing how it will work. So basically, it's behavior. And in my opinion and experience, such designs that are produced by a very specific way of thinking creates brittle tests. And who knows brittle tests? That you change one thing and suddenly, boom, everything blows up. Of course. And the follow-up is that those brittle tests might work as a diagnostic signal, like that they are whispering to us about the weak design that we just created. And while we are talking about brittle tests, who have ever heard or used mocks or was cursing because of mocks? Yeah, I thought so. Imagine that. So I believe that those brittle tests that are actually the diagnostic signal of a weak design might be because we are mocking objects, not roles that the consumers might need to collaborate with to get their job done. And you can say, whoa, 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 mocking objects, not roles? What do you mean by that? We are typically doing mocking, but no one ever thought about what we are mocking, right? Object, role, what's the difference? Who have heard or read or wrote these kind of classes? They have 17 dependencies, testing is impossible, class is named accordingly. Yeah, I thought so. I was doing that too, no worries. There is a great paper published in 2004 called Mock Roles, Not Objects by, I believe, former thought workers, and it's a white paper. And in this paper, they are presenting really interesting technique for designing. Even though it's named as mocking, don't be fooled by that, it's about designing. And in this paper, they are saying something like this. It's really a technique for identifying types in a system based on the roles that objects play. And I highlighted it's really, it's special to see roles that objects play. I was looking for other references and resources if other people in the world are also having this kind of thinking. And I found a video by Sandy Metz. Who knows Sandy? Okay. In the video, Polly wanted a message. She said something like this. Objects are more players of their roles rather than instances of their types. And of course, categories, definitions, boxes. What can be a general definition of a role? And I figured out something like this, that a role is a position or a function that one plays, defined by a specific set of responsibilities. And of course, responsibilities, they're defined as an ability to respond to a request or a call. Quite simple. By the way, have you ever talked to your software components? Okay, so maybe I'm the only crazy guy here. What would happen if we'll try to have a conversation with our fellow feedback service about the role? So, hi feedback service. Yo, what's up? I will be pretending I'm the feedback service, right? Well, we are wondering, what is your role? Role? What do you mean by role? What is expected from you? What do you need to know to be productive, to be useful? What are your responsibilities? Oh, responsibilities. Typically, I get all feedback, I give feedback, I approve feedback, and almost forgot I disapprove feedback too. So if we put those responsibilities onto the wall and read it aloud, what we just do, we get some pattern. We can look for a pattern. And actually, in linguistics, there is a pattern called SVO. So subject, verb, object. You have it in Norwegian, we have it in Polish, in English, right? And then, as an example, it will look as follows. So we'll have I give feedback. Really simple, primary school, no worries. Probably everyone understands that. If we try to put this pattern with colors onto the verbs and clamp everything together, we'll get something like this. So we'll get I get all feedback, I give feedback, I approve feedback, and I disapprove feedback. No magic, right? So we will be able to turn this into this, right? So yeah, probably interface segregation principle, every primary school student knows that. But I believe it yields some interesting properties. Because let's read it aloud, as humans will do. So, as a feedback service, I get all feedback, I give feedback, I approve feedback, and I disapprove feedback. And is it really a role that we are talking about? Right? I would say, yeah, we need to try. You can say, yeah, Damian, this is a toy example. One service, one interface, one concept. Like in my big system, we have tons of those. Okay, but let's be patient. Slow down and think a bit. Let's try to examine the language. How probable it is that the same person would eventually approve or disapprove feedback and give it. And then, and what about getting all feedback and giving it? Is it the same person? Or maybe we're actually talking about two different roles. So two different perspectives, not just one. But we saw a service. So if we just plot those two people or roles on the two different corners, we might get a person, like a customer, that bought a product and is asked to give a feedback. So this person will be concerned about evaluating something. And then there might be someone else that after that the feedback was given will evaluate how trustworthy it is. So this person will be interested in evaluating the evaluation, right? And then basically we are able to put those two roles into two different interfaces, right? To plot it like this. And we clearly see the different responsibilities and how can we assign them. And by that, our feedback service ceases to exist, as we discovered two roles. They were pulled from the problem space. And now we are talking about the feedback giver and feedback auditor. And maybe we are talking about collaborators, how they are collaborating together, those two roles. Who have ever heard or used maybe CRC card before? Okay. And who knows that book? Have you read it? Or just saw it? Okay, so it's free in internet. You don't need to be a pirate. It's really free. It's a great book. I totally recommend it. It's about designing. And even though you might not use object-oriented language, I think it's still worth it. So basically in this book, Rebecca, I think it was initially Kent Beck who brought this idea into our world. They figured out three concepts, so class, responsibilities, and collaborators. I made it candidate because we don't know if it will be class yet. That's why I put it as a candidate. And they were those things were like index cards where you write something down with like a real paper, real pen, the good old days, classics. But in this small exercise, we can just try to use it for our roles that we just found, right? So responsibilities will be gives feedback And we don't know about collaborators, except that it will be someone who knows about approving feedback, disapproving feedback, and getting all the feedback. And by examining the language, we might name this role or collaborator or candidate feedback giver. If we just go to the next candidate, we might plot everything and figure out with whom it's collaborating and what the name should be, like the feedback editor. So we already know that because we just saw it. And now we have the complete picture. So we use the ancient technique to explore something, right? And maybe when we are talking about the candidate responsibility collaborators, we are actually talking about the role responsibility and collaborators and its collaborations, right? So by looking at the role, looking for the role and bounding that role by those responsibilities, our site was focused on behaviors. And when I say behaviors, I have verbs in mind. And verbs are very, very special because they carry the context with them, right? The usage carries the context. And by focusing on the usage and on the context yielded by the usage, we are able to discover some interesting abstract ideas that are living in the problem domain. And about abstract ideas, let's just take this interface, like approve feedback, right? It accepts feedback, but is it any feedback that it can be approved? Can we approve already approved feedback? Sounds a bit like crazy. So maybe we are talking about given feedback, so feedback that was already given, not just any feedback. And then we have maybe a rule that only given feedback can become an evaluated feedback. And when I say evaluated, it means either approved or disapproved. And then feedback stops looking as an entity, like, whole big thing, as we are exploring the language. Eventually, we might model the domain or express the ideas that are living in the domain in the code, right? What about reading that aloud again? So it will be something like this. Evaluated feedback will be provided in the future when approved feedback is provided with given feedback. Well, it's a kind of academic definition, I would say. It doesn't sound right. So what is the sequence of appearance of the words? So we have evaluated feedback, approved feedback, and given feedback. So it's like promised result, responsibility, and required input. If we make an experiment and try to shuffle, right, try to put things into different places, what will we get? So let's put responsibility firstly, then we are getting required input, and then we are getting promised result. So responsibility followed by required input and followed by promised result. Then we get approved feedback, given feedback, evaluated feedback in the future. So let's read it aloud. It will be something like this. Approved feedback promises to turn given feedback into evaluated feedback at some point in the future. Let's play more with the language and try to translate it into more like coding, let's say. So promises to becomes equal sign. Turn x into y becomes x arrow y. And eventually, at some point in the future, becomes future of y. And let's put it onto the presentation, onto the wall, and we got this beautiful equation. If we add a type in the front of, we are getting some language. Who knows what language is it? Exactly. So this is the best language in the world, F#, which, and I'm not joking. The interesting part is that it allows us to model exactly how humans are thinking, right? By this kind of input, output, and so on, and also capture the very interesting abstract ideas living in the problem domain. And this also constitutes that responsibilities thinking is not bounded only to object orientation. It's much more profound way of thinking. I believe so. Okay, so because we were transforming given feedback into evaluated feedback, it's a kind of processing, right? And we know that processes can be multi-step, multifaceted, and so on. So maybe we are talking about feedback evaluation process. So just by exploring the area, we are getting much more insights that it might be really hard stuff to evaluate a feedback. Okay, so we all started this journey with an entity and entity-based service, but ended up eventually by talking about the roles, responsibilities, and their collaborations. So sending some messages and receiving messages and so on. So beautiful dance of roles and their responsibilities. And you might say, yeah, but it's exactly about the interface segregation principle, right? We know that, it's solid. But I have a problem with the interface segregation principle because it's very low level, it's very techy. And what we were talking about until now was responsibilities. So we are talking about responsibility segregation principle, right? It's something more like deeper or higher, depending on the perspective. And you might say, Damian, we told you about CQRS, right? It's all about responsibility segregation, and we were like, thinking about that. So maybe we should try this way of thinking in real CQRS, in real project. Because this was the toy example. One concept, one service, one interface. So, another domain. Imagine that we are working in a company and we are supposed to implement a new functionality. So, we need to handle important document, this is very important, processing, provided that a given partner, another concept, has this processing configured. And then we just need to store that newly processed document. So, this is our solution, like code, of course. Process important document command handler. It has a handle method accepting partner ID and important document to process. Then basically we are reading some application configuration from a service for the given partner ID, and then we are making a decision to do the processing or not. If yes, then we are using document processing service client. It's a client because it lives somewhere in the cloud. That is what enterprise architects told us before implementing that. It's living in the clouds, so that's why it's client. And then basically we are just storing that. If it's not configured, we are just storing without processing. Simple. It's a typical enterprise assignment. Read some data, make a decision, record, do some actions, and eventually record the decision. Really enterprise boring level, right? But we implemented that. But change never changes, right? This is the inevitable event of the life cycle of the software product. So the first change is actually about moving the configuration entry from configuration D to configuration A. And those lines would be the ones affected. So this is how, yeah, exactly. So this is our application configuration service interface, which is implemented by, you name it, Cosmos DB application configuration service. So someone was smart and this time put the Cosmos DB into the name. Like probably they were in my presentations back then. And here is the application configuration as a class that holds everything, probably dozens of configurations. And we were challenged to put like this document processing entry from configuration D to configuration A. Easy. Okay, so we changed it. There were some tests broken. We fixed that. Just, pick another item from the backlog and move on, right? While reflecting on that. Yeah, but those tests were kind of interesting because we touched configuration, and because command handler was depending on that, it changed. Should it? Maybe. Let's go to another change. Turns out that enterprise architects figured out that this web service I was talking about needs to be inlined. So instead of just being somewhere in the clouds, it will be like one of modules of our system. So this line would be affected. This is our interface, iDocument Processing Service client, and here's the implementation. Who will guess, right? So simple change probably, because we just need to inline it. So probably we'll copy the code and put it into our system. But it's named Document Processing Service Client, so the client suggests it's a web service, and it's a client for a web service. So should we name it as in-memory Document Processing Service Client? Well, probably our PR reviewers will just hit in our heads because of that. I don't know. So maybe we should name it accordingly and just drop the client. Great success, right? So we have the document processing service, everything is fine, ID does renaming, no test as broken. But yeah, move on to another exercise, no reflection. Third change, probably the most interesting one. So this time, not the enterprise architects, but business people came and said to us, oh, processing shouldn't happen if important document is already active document, whatever it means. Okay, turns out that we have this repository. Who knows what a repository is? Okay. Someone, somewhere, at some point of time, implemented this method, get active important documents, all of them, right? So why not reusing that? Probably it's a good idea. So we are just going to the code, we are getting all important documents by the given partner ID, then we are just making decision by that. Probably it will be not that performant, but who cares for that? We are agile, we are trying to ship it really quickly, right? And then we are just like throwing exception that it cannot be processed. That's fairly easy. Probably all of us did that. But here comes the problem. Turns out that this is our iDocument repository implementation, Cosmos DB document repository. Enterprise architects decided that this information about the document activeness is no longer available in the Cosmos DB. It will be available in the Azure Blob Storage as blobs. We don't know, we can't debate, we don't know why, no ADR. Basically, it is like it should be. And what happens to our repository? It has in the name Cosmos DB repository. Should we just inject another client and just rename it by dropping the Cosmos DB and have like document repository? Probably we'll just have one method that will use the blob storage client, the rest will just use the Cosmos client. Easy. So from the command handler perspective, nothing changed. But there might be some other problem, I would say, much more conceptual maybe. But this thing might bring the test down as we'll do so. We'll need to fix and mock and whatever by just introducing this little thing here. And exactly. So maybe we should just stop for a while and have a conversation with our command handler. I love that. I mean, like, because I pretend that I am two people at the same time. Yeah. OK, so hi. Hi, long time no see. We were wondering what is your task, and what do you need to know what do you need to get your job done? Oh, well, I need someone who provides information about all active documents. Then I need someone who provides information whether additional processing is required. And then, of course, I need someone who knows how to do the additional processing. And finally, I need someone who knows how to save an important document. A tiny question to you. You said someone who provides information about all active documents. Do you really need that much? When you asked me very explicitly, I would say no, I don't need that much information. I need someone to check if an important document that comes is already active. Basically, that's it. So if we take those needs and put them onto the wall, we'll get checking incoming important document activeness, checking additional processing requirement, processing incoming important document, and finally saving incoming important document. Wait, needs? Do command handlers have needs, like humans? And turns out that this paper, mock roles, not objects, again, brings this kind of perspective. And they call this technique need-driven development. And they say something like this. We use mock objects to let us write the code under tests as if it had everything it needs from its environment. This process shows us what an object's environment should be, so we can then provide it. And they call it a need-driven development. And the next quote from this great paper, TDD with mock objects guides interface design by services that objects requires, not just those it provides. In this process results in a system of narrow interfaces, each of which defines a role in an interaction between objects rather than a wide interface that describes all the features provided by a class. And we saw that, right? We saw huge interfaces before. Who knows that book? Who knows the book? Okay, great. So it's a great book from the authors of that paper. It's pretty old, I would say, but still it contains all those great, profound knowledge that we are talking about today. Yeah. So those needs can be, put as an interfaces. So each of the need might become an interface that later on can be satisfied by someone. We don't know by whom, but still it's a possibility. So we can put all those needs as interfaces. We don't need to go through all of them, because of the time, of course. But we can just think, how would this influence, what will be the impact on the command handler structure? So we'll get some if for checking the important document inactiveness requirement. Then we are just going to the decision if additional processing requirement is required, even though it doesn't sound well, but still we can do some renaming later on. But we are talking about different things than before. Then we are doing the processing, but not just a web service or in-memory something, but important document, additional processing collaborator or a role. And eventually we're just saving that. So code-wise, structure-wise, it's probably almost the same. We have a bunch of ifs, the flow is the same. Code-wise, it's even worse, because we have more interfaces, right? And this is the answer to the question, why? Because we created so many small interfaces, it might seem that we have more code. But actually, we were able to satisfy the needs by the handler itself. And do we get anything back? And in my opinion, we are getting smaller interfaces, much more of them, job security, more code to maintain, simple. No, we are expressing the collaborations between the roles, right? So we are actually doing the object orientation as Alan Kay was, telling us to do. And the interface keyword itself can be really ambiguous. Because so far, we were talking about consumer needs, consumer contracts, service providers, roles, responsibilities, and everything is represented by the interface keyword. So typically, new interface is created by a godlike creature, right? Like, designer, that knows everything about the system. And then this knowledge gets composed into the interfaces. We are creating big interfaces because we are getting all the knowledge from all the system into those things. And in my imaginary land that I live all day, all night, there is a language that allows us to express very precisely what we are dealing with. So we can have public responsibility I-save important document, public responsibility I-load important document, and then a role which is bounded by those responsibilities, having methods, as usual, interfaces. But of course, this language does not exist, and I don't have time to write it by my own. But still, I believe we are able to have this kind of perspective and way of thinking to see those roles and responsibilities in the wild. We have interfaces. But the problem with them is that we use interface technically, but behind that, there is much more profound concept, or concepts, I would say. So we saw during this short tale, I would say, that focusing on consumer needs and using this behavior-based of thinking, like it enabled us to reason on the higher levels, still being able to not lose the connection with the low-level details and the implementation, right? And suddenly we were able to think in more educated way, having a design-oriented side by using engineering principles and not just coding stuff, as we usually do. But this is harder, because it might happen that we might be a problem with answering a question, which then would require us to go to the people and talk, as usual people do, and then use this knowledge and understanding to apply it into code. And of course, like during this collaboration, I believe we won't talk about interfaces. We'll talk about responsibilities, roles, business capabilities, processes and steps. And eventually, it might lead to more code. But I am not afraid to have more code if I am embedding the understanding and knowledge that I just acquired, because it will be easier for me later and for other programmers too. Some key takeaways from today. Go and read this paper. Totally recommend it. Like, it's pretty old, but I believe you can find it useful. Then remember that you can always talk to your software components. Like, it can be your web services, your databases, or whatever you would like to. I believe that our brains are created for this kind of conversations. So I think we will see the personas over there, and we'll be able to have this collaboration and eventually figure out the roles, the responsibilities, and problems or needs. Then I advise to focus on modeling on behaviors, not just structures, so like nouns. We saw a couple of examples. By paying attention to the language, we are able to capture those subtle details in the domain. Then we should focus on the consumer needs, whether this is a real human, so customer of ours, or just a software component. And then we should, I believe, look for roles, responsibilities, and collaborators, because it changes the way you design things. And it doesn't matter if you talk about the interface, low-level detail, or high-level detail, or whatever it means, like the services, or even teams, I would say. And last thing, which is fairly important to me and my daily work, domain knowledge. I think you and me and everyone in the software industry should explore the area of business and human activity for the software that we are creating software solutions for, because there are numerous abstract ideas over there that we should, and probably that's a must sometimes for some industries, to be represented in the code, because it's very, very interesting, useful, and sometimes, like by the law, required. And you can say, Damian, are you a philosopher? Come on, like those topics. Like, is it really a practical thing? You might ask. Some of you might have this kind of like question or statement. It might work for these toy examples, right? But in the real project, there is no room for that. Maybe. Eric Evans, who knows Eric Evans? He said something like this, and Murfreed also had this quote today. Not all of the large system will be well designed. So maybe there are places when your design needs to be really sharp, needs to be really well designed. And the rest, okay, crude, maybe not. Then, of course, maybe some of you will say, yeah, Damian, eventually everything ends up in the database as a set of bytes. David Parnas, who knows David Parnas? Like, I would say father of the information hiding in the modularization world. He said something, eventually it all boils down to assignment of responsibilities. So we might assign the responsibility of certain things to our databases, but we should ask ourselves, is it really the thing we should do with them? And I would like to leave you with one statement that really impacted my thinking, and it is this. And engineers should be like werewolves. They should avoid silver bullets. My name is Damian, and it was a great pleasure to present this topic. You can find me on my blog, or if you scan the QR code, it will just lead you to the blog. Thank you very much.